here's two more problems. One is number 39, and this is one where it's all about shifting. There's no scaling because there's nothing multiplying x and there's nothing multiplying the cosine. So the amplitude is just going to be 1, and so that's not going to change. And the period is going to be our standard period 2 pi, but it's shifted in x and shifted in y. So let's see. It's going to be shifted, and this is where it can be tricky. Minus actually means shifted to the right by pi over 4. And it's shifted down because we're subtracting, we're taking our what we think of as our y value, the cosine, and then at the last minute we're just going to pull those down by 1. Okay. So let's look at our cosine standard graph. That looks like this, going to 2 pi. There's our landmark points. And we just want to shift those in these two different ways. And like I did in the last one, we're going to focus first on the start and ends of the period. And we know that the period hasn't changed. So this guy is 0, 1. I'm going to shift that right by pi over 4. That means add pi over 4 to the x-coordinate. And this means subtract pi over 4 from y. So 0, 1 is going to turn into pi over 4, 0. Okay. And I'm not going to graph yet. I want to figure out what the scales wants to be. This guy is going to be turned into, let's see, 2 pi plus pi over 4. Let's do common denominators. It's going to be 8 pi over 4 plus pi over 4, comma, 0. And that's 9 pi over 4, comma 0. Okay, so that's going to be, the first period is going to be out to 9 pi over 4. So let's use the same scale. Let's say that's 2 pi. And then just a little bit more than that is going to be 9 pi over 4. Well, let's be a little more careful than that. I know I'm not using graph paper or anything, but this is going to be pi over 2, 3 pi over 2. So here's the pi over 4s. They're 1/8 of those guys. And then here's the next one right there. So that's going to be 9 pi over 4. If we wanted to do a really good job, we would use graph paper, definitely, but I forgot to bring some out. Okay, and so right now we can graph these guys. There's the start of the cycle, there's the end of the cycle, and then the rest of them are going to be quarter the way in between. Now, that might be a little tricky to read off, but we could either just do it algebraically from the coordinates of these points, or let's try to do it the quartering way. This is 1 pi over 4, and there's 8 quarters here. 1, 2, 3, 4, 5, 6, 7, 8 quarters. So each one is just going to be 2 quarters all the way along. So here's the next x-coordinate. Okay. And I would be graphing it on the x-axis with y equals 0, but it's going to be down at 1. Okay, so here's the center line. -1. This is rather like the other one. And here's the bottom. -2. So down here, that's the center line. Then I go 2 more quarters. That's a pi over 2 to the bottom. And then 2 more quarters to the center line. And I'm good. And then continue. Now if you want, I would want some precision here. So what is that? It's pi over 4, 2 pi over 4, 3 pi over 4. This is 5 pi over 4. And this is 7 pi over 4. And then the next ones, let's get those carefully. We're just going up by 2 pi over 4 every time. 9 pi over 4, so this is going to be 11 pi over 4. Notice it turns out in this example to be all the odd multiples of pi over 4. 3, 5, 7, 11, 1 in fact here. That's 1 pi over 4. 11 pi over 4, 13 pi over 4, 15 pi over 4, and finally 17 pi over 4. It's not very legible, is it? Okay, 17 pi over 4 for that last one. And there's our shifted cosine function. Shifted down by 1 and shifted to the right by pi over 4. So, again, the main thing is taking those landmark points and shifting them in 2 ways. Now, the hardest one of all these was 41. And I did one like this in class, but they are tricky. When you combine stretching and shifting, that can be tricky. And what I've been trying to do so far is doing these in one fell swoop, not doing here's cosine x, and then cosine shifted in x, and then cosine shifted in x and y. You can do that, but it takes a long time. Here, it really, really is helpful to do an intermediate graph. So I'm going to quickly graph cosine. So we have that to look at. Okay, so there's cosine. And it turns out that usually the best way to do this is deal with the stretching first and then the shifting. So, and this guy is not too hard. It's just going to negate all y values. It's going to flip it upside down. That I can do at the same time as the 2x. So the first thing we can do is graph one period of y equals minus cosine 2x. And then we're going to put in the shift. Okay, so the cosine 2x, the period, is going to be 2 pi over 2 is pi. It's not shifted yet, purposely. And so it's just going to go out to pi. Now, I'm going to use a different scale here because I don't want it to be scrunched too much here. I'm going to call that pi. And so that's going to be pi over 2. Okay, so because of the minus sign, every y-coordinate is going to get flipped. So the 0, 1 becomes a 0, minus 1. And the end of the cycle is going to be at pi, because of the scrunch, comma minus 1. The middle of the cycle is going to be at pi over 2 because of the scrunch, but up high. And then here's the... Okay, now let me carefully label these. That's pi over 4 and 3 pi over 4. They're all the quarters between 0 and pi, just 1 quarter, 2 quarter, 3 quarter, 4 quarter. So there's the upside down and scrunched version. That's the minus cosine 2x. Now we're ready to put in that shift. And let's see. Yeah, we've got plenty of room. Okay. So this guy is going to shift left by pi over 3. So since it's shifting left, if I'm going to take this period and shift it left, I'm going to need some negative stuff. So I'm going to make sure to have some room over on the negative side. And I want to get a good idea of where the start and end of the cycle are and exactly what these points are going to be. Okay, so let me just do a little table. 0, comma minus 1 is going to go to minus pi over 3 minus 1. So here I'm being very careful because the pi over 3 and the pi over 2s are going to interact in a complicated way. And so I just want to be real careful about that. Pi over 4, 0 is going to go to, well, I'm not shifting the y. Well, let's see. Pi over 4 minus pi over 3. Ooh, goodness gracious. Pi over 4 minus pi over 3. Let's see if I have some room for scratch. Let's just do it up here. Pi over 4 minus pi over 3. That's going to be some common denominator action. That's 3 pi over 12 minus 4 pi over 12 is minus pi over 12. Notice the pi's don't do anything interesting. They all are a common factor in the whole thing. This is basically the same computation as 1/4 minus a third is minus a 12th, which you do need common denominators for, but don't let the pi freak you out. Okay, looks like I'm going to run this over and just finish it in the next video. Sorry for the time involved here. So that's going to be minus pi over 12. Then let's see if I can just at least finish this process. Pi over 2, 0. We're going to subtract pi over 3 from pi over 2. That turns out to be pi over 6. Oh, but this is 1. Sorry, pi over 2, 1. That's this point. And 3 pi over 4, comma 0. That's 9/12 minus 4/12. That's 5 pi over 12, comma 0. And the very last one, we'll do it on the next video anyway. Okay.